Alright, so let's go and get started. We're going to talk about Skills 3, Level 3, where we are going to go ahead and graph a system of equations and then identify the slope of parallel and perpendicular lines. Okay, so we kind of went ahead and maybe you remember this from last year, but there are 3 different types of solutions when we're looking at a system of equations. And again, a system of equations is just 2 linear equations. Okay. So there is one. So the first option is one solution where they intersect at one point right there. And this is my x comma y. Okay. There is another one where the 2 lines, they never touch. So then this one's going to be no solution. And then there's this one where there's actually, if you kind of look, I guess it's easier on my end, but if you look at these two lines, right, there are actually 2 lines, but they are the same line. So this is when we have infinitely many solutions, okay? Just a little review on how we find the solutions of a system, okay? But with system of equations, there could be parallel lines. And here, they always have no solution since they never intersect, right? And then we do have perpendicular lines, where in this case, they always have one solution. And again, this is my x comma y. Okay. So an example one, it's asking us to go ahead and graph the 2 lines using my Desmos graphing calculator. So this is when I'm going to go ahead and split screen it. And you guys can do this as well. And I'm going to go ahead and type these 2 equations into my calculator. So I have y is equal to 2x minus 1. And then I have y is equal to 2x plus 3. And we see here that we have a set of parallel lines, okay? So you could go ahead and graph it, right? If I were to go ahead and graph it, let's go ahead and graph the first one, so my red line in this case. And this is how you can kind of use your calculator to go ahead and check it. But my red line, right, my b value is at -1, so there's that guy. And then my slope is 2/1, so I'm going to go up 2 to the right 1. So there's my first line. Okay, and then if I were to go ahead and take away that line and graph my blue line, my y-intercept is at 3, and same thing, my slope is at 2/1. So 3, I'm going to go up 2 to the right 1, there's my next point. So then there are my 2 parallel lines, right? If I go back to my graphing calculator, right, there are those 2 lines right there. Okay, so when we're talking about this guy right here, these lines are parallel because they never touch, cross, or intersect. Okay, because, and so this is like the big guy right here, and so yep, they are parallel, they never touch, cross, and intersect, and because, and what do we think about my slope? If I were to go ahead and look at my slope, what do we notice? Right, we notice that they are the same slope. So because, I'm going to say the slopes are the same. Okay, so right, you notice that in these 2 equations, the system of equations, we have the same slope. Okay, so let's go ahead and move on to B. Let's go ahead and first, actually, let's go ahead and graph it by hand. So I'm going to graph my first line. My b value is at -4, and my slope is at 2/3. So I'm going to start at -4. I'm going to go up 2, 1, 2, right 3. There's my first line right there. And I'm actually going to go ahead and graph that first, just to check and see if we got it right. So I have y is equal to 2/3. Oops. 2/3x minus 4. Okay, that looks about right. Then I'm going to go and graph my second one. Looks like my b value is at 4 and my slope is at a -3/2. So I'm going to start at 4. I'm going to go down 3, 1, 2, 3, to the right 2. And there's my second line right there. Okay, and I'm going to go and graph this one. I have y is equal to -3/2, x plus 4, right? And they look like the same exact thing. Now, they do intersect at this solid point right here. It's not a solid point if I'm looking at my graph, right? That's not a targeted point nicely on my graph, so everything looks good. Okay, so here, these lines, if you kind of tilt your head a little bit, right, we notice that these lines are actually perpendicular. So I'm going to say these lines are perpendicular. Right, and this one is because the lines intersect at one point. Okay, and we know that they actually create 90-degree angles. So in this picture right here, I'm actually going to go ahead and add in my 90-degree angle measurement. So you could say, and form 4 90-degree angles. Okay, and if I look back at my slopes, right, we have a 2/3 and we have a -3/2, right? They are the same, like they both have a 2, they both have a 3, right? My first one is a 2/3, my second one, what happens is that it flips. So instead of 2/3, it flips to 3/2, and then it becomes negative. So in this case, the slopes are opposites. So what happens is that the original just becomes negative, and then it's the reciprocal. The reciprocal means that it flips. So this, I could say, flips. Okay, right? We see that we started with, and we could talk about over here, 2/3. I'm going to go ahead and take my original. I'm going to go ahead and make it negative and flip the fraction. And that is now my perpendicular slope. Okay. So if I'm looking at this chart down here, it kind of explains everything, but the slopes of the parallel lines, this actually takes the same slope. And then we have the slopes of a perpendicular line. They are opposite reciprocals. Okay, so this is when we take the original, or like the first equation slope, and then we're going to take the negative of the original and flip the fraction. Okay, so let's go ahead and look at page 16. Okay, so my original slope, it looks like is a -6, right? The parallel slope is the same exact thing, so it's also going to be -6. And then the perpendicular slope, I'm going to go ahead and take my original slope. I'm going to negate it, which I'm going to take -6 times a negative, which we know is a positive, so it becomes +6. If I were to look at 6 as a fraction, right, 6 divided by what number gives me 6? It's just going to be 6/1. So the perpendicular slope is going to be a positive 1/6. Okay. Okay, the second one, my slope is a -1/3. My parallel slope is the same exact thing. My perpendicular slope, it does go on and change, so I'm going to go and multiply it by a negative. -1/3 times negative is a positive, and then I'm just going to flip the fraction. So this then becomes 3/1, or in other words, 3. Okay. The second one we are going to have to go and solve, right? Y is not by itself, so I have to divide every single thing by 4. So y is equal to -1/4 x plus 3. So now my slope is a negative 1 over 4. Parallel slope is the same exact thing. My perpendicular slope, I'm going to take the negation of it. So I'm going to take negative times negative 1/4. That becomes a positive. And then I'm going to flip the fraction. This one becomes 4 over 1. Or in other words, 4. Okay, and then I'm going to go ahead and solve for this guy because y is not by itself. Have to go and solve for y. I'm going to go and subtract both sides by 4x. I get 2y is equal to negative 4x plus 2. And then we have to divide every single thing by 2. So we get y is equal to negative 2x plus 1. Okay, now my slope is negative 2. My parallel slope is the same exact thing. And then I'm going to go ahead and take a negative 2 times negative, which is a positive. Right? Negative 2 is really negative 2 over 1. So this becomes 1/2. Okay. So the biggest difference, right, parallel slope, it stays the same. Perpendicular slope, we have to go and multiply it by a negative, and then we have to flip the fraction. Okay. Now the last part, right, it says to determine if the lines are parallel, perpendicular, or neither, and it's asking us to show our work to justify your answer. Now the showing of our work in this case, guys, is super easy. We're going to go ahead and use Desmos. Okay, so my first one, I'm going to go and split screen again. I'm going to go ahead and type in these two equations. I have y is equal to 2x minus 5. And then I have y is equal to negative 1/2 x plus 7. And let's go and take a look. Cool, so we see that there is a point of intersection, right? So it cannot be parallel. If I kind of go ahead and look at this graph, right, it kind of looks like they're perpendicular to each other, or they are having 90-degree angles. But let's go ahead and check my slopes now that we know that rule. Okay, so I have my first slope, which is 2. My second slope is negative 1/2. So my original slope is 2. So then let's check to see my perpendicular slope. So I'm going to take the 2 and I'm going to go ahead and negate it, right? And I'm going to flip the fraction. So it's really 2 over 1. I'm going to take the negative version of it and flip the fraction. That gives me negative 1/2, which, right, is the slope for my second equation. So this one is actually perpendicular. So we were right. Like, we could possibly tell from my graphs that they are perpendicular, but it's always good to go and check. Okay, so perpendicular because the slopes are opposites. That would be a great reasoning. Okay, let's go ahead and check my second equation. So again, we can go ahead and graph into Desmos, but let's actually go ahead and try solving this on our own. My second equation does not have y by itself, so I'm going to actually go ahead and solve for y. Right, I subtracted negative 5x on both sides. And then we have negative y is equal to negative 5x minus 3, right? This is a sneaky negative 1, so I have to divide everything by negative 1. So we get y is equal to 5x plus 3. So now here are my two equations. I have y is equal to 5x minus 1, and I have y is equal to 5x plus 3. If I'm looking at my slopes, they're the same. And what do we know? What happens when we have the same slope? Right? We know that these are then parallel. Parallel because the same slope. But before we go ahead and circle our answer, square our answer, whatever, let's go and check to see our answers on my Desmos calculator. So I'm going to type these two equations in. 5x plus 3. Yep, cool. If I were to zoom out super far, right, we see that the lines never touch, so they are in fact parallel. Perfect, and that is it for notes today.